Alright, so what I want to do next is link the frequency tables to the statistical diagrams. So they have two basic statistical diagrams, the bar chart and the pie graph are some of the basic statistical diagrams and popular ones for CXA especially. So for the bar graph, we just use a series of bars, and the heights of the bars tell you how much of a specific item that you have. So here we have a bar graph showing the age of students in a Form 5 class. So this is the frequency here, and here we have the age in years. You must always label the axes. The horizontal axis is called the x-axis, the vertical is called the y, and we'll go more in detail into that when we're doing graphing in particular. So this is just an introduction to the bar graph. So here we have 15-year-olds, 16-year-olds, 17-year-olds, and 18-year-olds in this Form 5 class. And I want to transfer that now. The question they're asking is construct a frequency table from the given graph. So again, if I want to construct a frequency table, I'm going to head up the headings of my table. Obviously, one going to be frequency, or how often the specific values occurring, and what will be the specific values this time that I'm going to put on my table. So what the specific number is going to be? The specific number is the ages of the students, and it has a unit. The unit going to be in years. And what ages the students could have? The students have the range in age from 15 to 18, 15, 16, 17, 18. So what I want now is how many 15-year-olds they have in the class. But they didn't give me it like the last question. They give them in a table, in a statistical diagram, a bar graph. So 5, 10, 15. So that means reading the scale, each one of these is going to be 1, 2, 3, 4, 6, 7, 8, 9, and so on. So watching the height of the bar for the 15-year-olds, it went to a height of 2 blocks more than 5, so that's 7. So we have a height of 7 there, meaning 7 students had an age of 15. Same thing here. How high did the bar for the 16-year-olds go? I hope it's all easy to see on the graph. So that one reaching here, so that's 10, 11, 12, 13, 14, 15. So I have 13 16-year-olds, which is the usual age you expect some students to be around that age in Form 5 or Form 4. And then we continue. How many 17-year-olds? So this went to a height of 4, and you can see we only had one 18-year-old in the class. So that will be 4 and 1. So we complete the table from the graph. We just read the information off the graph, which is a good skill to have. Something they will test at some point to make sure you could analyze and read information off a graph. So we have our frequency table now. So now we want to know how many students are in the class. So let's go back to the table or the diagram. So we had 7 15-year-olds, 13 16-year-olds, 4 17-year-olds, 1 18-year-old. Same thing here. 7 15-year-olds, 13 16-year-olds, 4 17-year-olds, 1 18-year-old. So for me to get how much children in the class, I want the total frequency. So I want to add up these numbers. 13 add 7 is 24, add 1, 25. So there are 25 students in this class. Now, just like the last one, they want the mean age of students in the class. Unlike the last one though, I don't have the raw data. I just had the table, the bar graph, and from the bar graph I get the table. But because I have the table, I could find the mean. But to find the mean, I need to do a totals column. So I'm going to do up my totals column with my bend lines. Because I'm holding the phone, I can't use the ruler, right? That'll be the excuse. So, and just like before, since we have 7 15-year-olds, I want to know how much all of those ages of the 15-year-olds going to add up to. So I multiply it out just like last time. I'm going to change here 15 by 7. So when I multiply that out, I get in 105. I have 13 16-year-olds, so all of these 16-year-olds, if I was to add up 16 plus 16 plus 16 plus 16, 13 times, 16 by 13, I'm going to get 208. If I was to add up the 4 17-year-olds, because remember we want to add up all the ages of these 25 children, I'm going to get 68. And 1 18-year-old, easy, 18. I want to add up all these numbers. I think we will get in 499. Just double check on the next side here. Yes, sorry, 399. So we get in 399. Sorry about that. So all the ages going to add up to 399. So when I'm going to find the mean, it's going to be 399. How much all the ages add up to when you add up these numbers. divided by how much numbers add up. Now again, I want to show it with this one in particular. Even though it looks like it was 4 numbers that I add up, if I was to divide this by 4, and I'll do it in pencil just to show you, 400 divided by 4 is 100. So you're trying to determine the average age of the children in a Form 5 class is 100 years. You realize why that doesn't make sense. It's really going to be the amount of children in the class, because it's all their ages that add up. So it has to be divided by 25. When I divide it by 25, I expecting my answer to be between here, and it is. I get in 15.96 years, which is approximately 16 years, which again is around the average age of a Form 5 student. The last part, and I just want to show you how they could incorporate probability into these questions as well before we try some on our own. What is the probability of randomly picking a student? Again, you realize random, just to make it fair. It's not like a singling out a student. What's the probability of randomly picking a student that is over 16? So 2 things have to happen here. If I want the probability, it must be out of something, because it's going to be a fraction. So I pick in from this Form 5 class. How much people are available to pick from this Form 5 class here? So we already figured out that if I'm going to pick from the class, it have 25 children to pick from. So I pick in from the 25 students. Just like if I was rolling a die, it have 6 options that could come up. Here I have 25 options. If I was flipping a coin, it have 2 options, either head or tails. If I was going to play a 1 mark in playway, they have 36 options to choose. So it would be out of 36 that are picking a number from that 36. So the bottom number is the sample space, which in this case is 25. For our dice was 6, for one dice, sorry, was 6, and for the coin was 2 heads or tails. Here is 25 children are allowed to pick from. The specific part, meaning the top number now, is over 16. What does over 16 mean? And this is where the understanding of the English language will come in. So what's the probability of randomly picking a student that is over 16? Are we including the 16-year-olds? No, because over 16 means, I'm not checking 16, but what comes after 16, which is 17 and 18. So I'm looking at picking a 17 or 18-year-old in the class once he's over 16. So let me see how much 17 and 18-year-olds we have. So going back to the table, again, this was just for the mean. These are the 17 and 18-year-olds we have in the class, and you might see it on the bar graph as well. So we had 4 17-year-olds and 1 18-year-old. So we have 4 people who are 17 and 1 who are 18, 1 who's 18. So how much people in the class are over 16? 4 plus 1, we have 5 people over 16. So in other words, if I was going to pick somebody who's over 16, I have a 5 in 25 chance of picking somebody who's over 16. And if I wanted, again, I could break that down, because sometimes for the multiple choice they would break it down, sometimes they won't. So I have a 1 in 5 chance of picking somebody from the class who would be 17 or 18, or other words, over 16. And that's how you incorporate all of these pieces into a full question.